Hi everyone, welcome back. In this video, I'll be explaining how you can calculate the determinant of a 3 by 3 matrix. In the last video, I defined a determinant as a value that can be computed from the element of a square matrix. In essence, you can only find the determinant of a square matrix. If a matrix is not a square matrix, that is a matrix whereby the number of rows is equal to the number of columns, you cannot take the determinant. So in it, you can only find the determinant of 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix, and so on. And in general, determinants can only be found when you have a matrix m by m, when the number of rows is equal to the number of columns. And don't forget, I told you when you have a determinant, when you have a matrix like this, 1, 2, 3, 4, indeed, A is what? A is a square matrix, a 2 by 2 matrix for that matter. Then your determinant of A, which is the same thing as this, so mean you are going to multiply the elements along the leading or main diagonal, that is 1 multiplied by 4 minus the elements along the second diagonal, that is 2 multiplied by 3. Then I'm going to have 4 minus 6, which is equal to minus 2. You can see it is very simple, isn't it? So since you now know how to find the determinant of a 2 by 2 matrix, how do we now find the determinant of 3 by 3 matrix? Suppose my A is now 6, 3, 2. Don't forget you read matrix row wise. 7, 0, 4, 5, 2, 6. So this is a 3 by 3 matrix. So you can't use the approach I explained for that of 2 by 2 matrix. So, but if you want to find the determinant of A now, that is that A, which is also the same thing as this, that is the determinant of your matrix, which is 3 by 3. Then what you have to note or what you have to do is to what? Is to calculate or you compute the minus. We call something minus as well as cofactors. I'm going to explain in a moment. When you say minor of a matrix, each element of a matrix has its own minor. When I say minor of a matrix is obtained by clearing the row as well as the elements, the row as well as the elements, the row as well as the column of that element. What I'm trying to say in essence is that if I want to know the minor of 6, recall this is my 6, my element 6. Then the minor of element 6 can be obtained by clearing the row where you can find 6, where C is, as well as the what? As well as the column. You can see at the end of the day, you are going to have what? A determinant of 2 by 2. So which is 0, 4, 2, 6, which you can compute straight away by doing what? By multiplying the element along the leading diagonal minus the element along the second diagonal. You understand now? So you are going to do that for what? For each of the elements. You find the element of that, the minus of that matrix. If that is cleared, you know how to find the minor of a matrix now. How do I now find the cofactor? So the cofactor, like that is the sign on each of what? On each of these elements. I hope you understand now. So the minor of an element in the determinant, including its place sign, is called what? Is called its cofactor. I hope you understand now. And the cofactor, you start by what? By numbering each of the elements from the top left hand corner by plus, minus, plus, and you can what? You can actually interact them this way. So the sign of the cofactor follow this pattern. You have minus, that is alternatively the positive or negative sign, alternative selves from the top left hand corner. So plus, minus, plus, minus, plus. Although I'm going to explain how we obtain what? This plus minus. You understand now? Recall that the position of this element 6, you understand that it is in row 1, column 1. Row 1, column 1. So, and the position of this element 4 is what? Row 2, column 3. You understand now? So, if you want to know whether the cofactor of a matrix will has positive sign or negative sign, then you are going to add these subscripts together. And if the subscripts give you even, if the subscripts give you maybe ij, so then if ij is equal to even, so then you are going to have what? So let me rewrite it very well in terms of this term. So that is, this is going to be positive if I plus j gives you even. And you are going to have negative ei plus j give you odd. For example, now you know 1 plus 1 here, row 1, column 1 will give me 2. 2 is even, then I'm going to have plus here. This is row 2, column 3. If you add 2 and 3 together, I'm going to have 5. 5 which is odd. Then the sign on the cofactor will be what? Will be negative. Likewise, you know this is row 3, column 2. That is 2 plus 3. You understand that? That's 5. We give you odd number. Then I'm going to have negative on it. Don't forget I said the minor of an element determinant, including its place sign, is called what? It's called a cofactor. So this is the cofactor. I hope you understand now. So, and if you now want to find the determinant of a matrix, so to find the determinant of matrix, it is achieved by carrying out the expansion along the 3 row of the 3 column. I can find the determinant by considering this row or any of the rows. You can find it by considering any of the column. You will see what I mean now. So whether you use the minor of column 1 or the minor of row 3, irrespective of the minor you use, so then you are going to arrive at the same result. So let's do that now. You know the question again is, I have 6, 3, 2, 7, 0, 4, 5, 2, 6. So if you want to find the determinant of this matrix, don't forget you have to put your cofactor first. The cofactor is plus. Don't forget how I said you are going to obtain it. Once you add the subscript of the position of the element, if it gives you even, then you are going to have positive. You know this is on at what? Row 1, column 1. 1 plus 1 is 2, which is even. This is at row 1, column 2. 1 plus 2 is 3, which is odd, minus. Then I said you are going to be alternating it. Plus, minus, plus. I hope you understand now. So then when you now want to take it, you now take the element one by one. So determinant is obtained by what? By taking the element one by one. You understand now? And you find the sum of the products of its cofactor. So that is the sum of the product of an element and its cofactor. Maybe I want to consider this row, for example. So then you are now going to find the sum of the each of the elements and its cofactor. Then you take it one by one. Plus 6. Okay, what is the cofactor of 6? Don't forget I told you. What is the minor of 6? Minor is obtained by clearing the row as well as the column. Then what am I going to have? So 0, 4, 2, 6. Then what is the second cofactor? Minus 3. Remember I said, so you can obtain determinant by what? By taking the sum of the product of an element and its cofactor. Okay, you still take the minor of 3. What is minor of 3? Minor is obtained by clearing the row as well as the column where you can have 3. What do you have? Like maybe I should change the marker so that you can see that clearly. So the row is row as well as the column. So what do you have left? This is 7, 4, 5, 6. And lastly, the last element. So you also clear the row as well as what? As well as the column. You know this is the row as well as the column. What do you have left? Then I have 7, 0, 5, 2. And from here you can, conclude that since we know how to find the determinant of 2 by 2 matrix just by multiplying the element along the leading diagonal minus the element along the second diagonal. Then this is going to give you 6. 0 times 6, 0 minus 8. minus 3 into what? 42 minus 20 plus 2 into what? 14 minus 0. Then I'm going to have 6 into minus 8 minus 3 into what is 42 minus, that will give you 22 plus 2 into 14. Then if you multiply it together, this is going to give you minus 48 minus 66 plus what? Plus 24. So minus 48 minus 66 will give me what? That's minus 114 plus 24. That's going to give me what? Minus 90. That's going to give you negative 90 if we don't make a mistake. Let us check it again. I think there is an error somewhere. We have 632 704 526 0426 7456 7052. Then it's going to give me 0 minus 8 42 minus 20 plus 2 into what? 14 minus 0. Yeah. So then 6 into minus 8 minus 3 into 42 minus 20 will give me 22. Then plus 2 into, yeah, I made a mistake here. This should be 28. 40 times 2 is 28. So then minus 28, that's going to give me minus 86. I hope you understand. But like I've said, you can take the minor or the cofactor of what? Of any of the row as well as any of the column. So, but I used to advise students to take the column or row whereby you have at least a 0. The reason why you should do that is that if you have, an element that is 0, and you know that you are going to take the sum of the product of an element as well as its cofactor. So an element that is 0, it means the cofactor is going to be 0. So it will reduce your stress. So for example, now let us choose the second row and see what we are going to have. So we have what? 632 again, 704 526. Okay, first thing to do is to what? To put your cofactor. This plus minus plus minus plus minus plus minus plus. Let's say I want to consider this what? I want to consider this row. Recall I told you you can take any of the row or any of the column and take their what? And take their cofactor. You are going to arrive at the same result. But I told you it is advisable to take, the row or the column where at least one of the elements is 0. You understand now? So that you have what? You have a lesser work to do. Okay, now let's say I want to consider this. Don't forget, determinant is the sum of the products of an element as well as their cofactor. So then you take the first one, minus 7. So what is what? What is the minor of 7? It is obtained by clearing the row as well as the column. Maybe I should show it here. This is the row, this is the column. What do you have left? We have 0, 4, 2, 6. Then the next one plus 0. So you also clear the row as well as the column. What is the row? This is the column. What do you have left? 6, 3, 5, 6. 6, 3. Sorry. We clear this as well. We have 6, 2, 5, 6. Then lastly, plus, sorry, minus, the cofactor here is minus. Then you take the what? The minor of 4 as well. What will be the minor of 4? You clear the row as well as the column. What do I have left? 7052. So you have 7052. I hope you understand now. Then you can now simplify it further. We know that to find the determinant of 2 by 2 matrix, just multiply the element along the leading diagonal minus element along the main diagonal. So this is going to be 0 times 6, 0 minus 8 plus 0 into what? 36 minus 10 minus, oh, we didn't put here. I think 4 should be here. So minus 4 into what? 10 minus 0. So then I'm going to have minus 7 into minus 8 plus 0 into 26 minus 4 into 10. You see that this guy will cancel, will be 0. 0 times 26 is equal to 26. You see the advantage of what? Of taking the row or column whereby at least one of the elements is 0. So because even if if the cofactor is 3,000, you are going to have 0 at the end of the day. So then this is going to give me minus 56 plus 0 minus 40. So minus 56 plus 0, so minus 40, that's going to give me, then it means I made a mistake somewhere. Sorry about that. So let us take it again. No, I made a mistake. This is 14, not 10. 7 times 2 is what? 14 minus 10. I hope you understand. And so this is going to be 14. And what is minus 4? And this should be positive, I think so. Minus times minus is plus. That's 56. So 14 times 4, this is 6. Remainder 1. That's minus what? Minus 56. There's an error somewhere. Let us check it again. I'm sorry about that. So if you clear the row as well as the column of this guy, I think that's where the error is. We are considering this guy. If you clear the row as well as the column, I'm going to have 3, 2, 2, 6. 3, 2, 2, 6. Okay. And 3, 2, that's going to be 18 minus 4. 18 minus 4. And 18 minus 4 is going to give me what? 18 minus 4 is going to give me 14. I hope you understand now. So it's going to give me 14. It's going to be, what is 14 times 7? That's 8, remainder 2. So 9, that's minus 98. Minus 98. Or maybe, sorry, let us do it clearly. Let us do it clearly. Let me do it clearly so that it doesn't create a problem for us. So this is the matrix again. We have 6, 3, 2, 7, 0, 4, 5, 2, 6. Then I want to consider this, right? We know the cofactor is minus, plus, minus. Okay. You take it one by one. So you are going to have minus 7. What is the cofactor of what? What is the minor of 7 by clearing the row as well as the column? What do you have left? 3, 2, 2, 6. Then plus 0. The minor of 0 will be what? You clear the row as well as the column. We have 6, 2, 5, 6. Then minus this guy, the row, as well as the column. Then we have 6, 3, 5, 2. Don't forget your 4. So and this one is going to be minus 7 into 18 minus 4, Abi, plus 0. You don't need to stress yourself here. Then minus 4 into 12 minus 15. So then it's going to give me minus 7 into 14 plus 0 minus 4 into what? Minus 3. So this is going to give me minus 98 plus 12. So if you say minus 98 plus 12, you see it's going to give you minus 86. So which is the same result for this. So what I'm trying to say in essence is that irrespective of irrespective of the row or the column you take, you are going to arrive at the same result. You are going to arrive at the same result. If that is clear, let me give you another example, which is more or less like question. So example, so if you have this question, that is if the determinant of 3, 2 minus 1, 4, 1, 1, 1x 3 is equal to 2, find what? Find the value of x. We have to find the value of x. We call determinant. To find determinant of 3 by 3 is not difficult. Just know your cofactor. Which element are you going to what? Are you going to multiply out? Suppose I want to take this element, you have to indicate the sign on the cofactor. You have plus, minus, plus. I hope you understand. And since the determinant is the sum of the product of an element and its cofactor, then you take the elements one by one. You have plus 3, okay? And you take the minor of 3. Don't forget minor is obtained by clearing the row as well as the column. Then I have 1, 1, x 3. You understand now? Then minus 2, which is the second element. You also clear the row as well as the column. This is the row, this is the column. What do you have left? 4, 1, 1, 3. Then minus 1. You know it's supposed to be plus, but you have minus 1. Plus times minus is minus. You also clear you take the minus obtained by clearing the row as well as the column. What do I have left? 4, 1, 1x. Then if you simplify it further, I'm going to have plus 3. Okay, don't forget determinant is obtained by multiplying the element along the leading diagonal minus element along the main diagonal. That's going to give you 3 minus x. Minus 2 into what? 12 minus 1, 4 times 3, you understand now. So minus 1. Then minus 1 into 4 times x, 4x minus 1. So and this is equal to 2. Sorry, you have to equate it to 2 because we are giving it as an equation. So it's equal to 2. Now, if you simplify further, then I'm going to have what? 3 times 3, that's going to give me 9 minus 3x minus 24 plus 2 minus 4x plus 1 is equal to 2. I hope you understand now. So let us collect the like times. Then this one is going to give me 9 plus 2, 11. That is 12. 12 minus 24, that's minus 12. Minus 3x minus 4x, that's what? Minus 7x equal to 2. Then if you collect the like time, you have minus 7x equal to 2 plus what? 12. Minus 7x equal to what? 14. And s implies what? This implies s equal to 14 divided by minus 7, which is equal to minus 2. So it means your s is equal to minus 2. You can see it is not difficult. So this is how you are going to be finding the determinant of 3 by 3. Just establish which row or the column you want to what? You want to take the cofactor. So and don't forget you can if you take any of the row or any of the column like I've established, you are going to obtain the same result. And then immediately you locate the row or the column you want to use. Just take the elements one by one and their cofactor. And don't forget the minor of an element is obtained by what? By clearing the row as well as the column. So this is how you are going to be finding the determinant of 3 by 3. In the next video, I'm going to explain law of zeros. So that is an interesting method of finding the determinant of a 3 by 3 matrix. If you like this video, please don't forget to like, share, and subscribe. I will see you in the next video. Thank you.